Right, good morning everybody. My name's Ross Lawley. I'm a Python engineer at 10gen, and today we're going to go through and look at using Mongodb with Python, how to install it, how to run some queries. If you go to files.ep in your browser and then go to the training files, you should be able to see all the files that we'll need, or most of the files that we'll need for getting up and started. So the first thing to do is in workshop PDFs, there is the initial one, lesson 1.0. So if you download this PDF, it'll give instructions of what we're going to go through to get MongoDB up and running for you. So that's on files.ep. Well, I'll take it that everyone can can see the PDF now, or will be able to in a couple of minutes. So the first thing we're going to do is we're going to download the new binaries as well from the files.ep. Under MongoDB, there's a folder called MongoDB binaries, and there are basically the recent or most recent binaries available for MongoDB, which is in the unstable branch, which gives some of the new features. Hi.
We're going to use MongoDB for Python 2 or Python 3?
Okay, so when we come to installing it, we'll use it for Python 2, just so we can do stuff for the ODM later. But first of all, we need to get MongoDB up and running itself. So under the binaries, there are various ones for Windows, OS X, Linux, and SunOS. So download whichever one is your actual flavor that you need. And when you download and extract it, what you'll find is there'll be a bin directory which has all the commands to run MongoDB to get up and running. I think what we'll do is if you just install that into a tutorial folder, and we'll keep everything nested there, and we'll keep the data there as well, and we can go through later on. But as soon as we've got the database up and running, we can get PyMongo, the Python adapter, running as well, and ensure that we can just connect and hook up to MongoDB. Okay, so the reason why I put 2.12 on is just so you can, there's one exercise later on that uses one of the new features up and coming. If you don't want to do that exercise, it's fine. If you already have it installed, that's okay too. But you won't be able to see the new aggregation framework, which is an improvement over sort of doing MapReduce functionality. And that actually also leads me to a good point. Who here's used MongoDB before? So I have a couple of people. So, okay, he's done a tutorial online. Okay, does everyone know what MongoDB is? Or does anybody know, or does anybody not know what MongoDB is? It's probably a better question. No, everyone's happy with that. Good. So when we're telling you to run Mongodb, the Mongodb here, actually that's here we go. So when we tell you to run the Mongodb here, there are a number of command line switches that you can pass in. The first one here is actually saying where you want the data files to exist and persist to. So we're just saying local, so if you have it in the tutorials folder and you also have the binaries there as well, if you no longer want to uninstall it, you can just get rid of the tutorial folder and you've blasted away everything. So it's just to keep it all together. The other aspect is no journal, is just literally not to set up journaling because we're not going to use it in this for this exercise. So it just saves the amount of disk space that it will use. And the final part is the ampersand is just to put it in the background. So most of these, when you download the PDFs, when we come to the shell versions, you'll be able to copy and paste the examples in and see them run. Okay. So if people can let me know when they've got PyMongo installed and have tested the final part at the bottom where they import PyMongo and don't get any errors, we'll move on to actually using it and playing around with some of the data. So if anyone's got any questions throughout this, just raise your hand and I'll come over, or if you're stuck on any part, that's fine. But what I'll do is I'm going to try and just run through this. I know people will be at different levels, that just is kind of inevitable. But you do have the PDFs to follow as well, which will give you all the instructions. And everything should work because I'm running them in a IPython notebook and it runs them for you. So once you have a connection up and running to your MongoDB, the next thing is to be able to connect to a database. And one of the interesting or unusual things that you could describe about this is, with MongoDB, you don't have to declare or create a database. You just have to start using it, which is very different to most people's expectations. So when you do things like, for example, we have a connection and we do connection.tutorial. Tutorial will be the database that will be created as soon as you start creating files or inserting some data to it. You can also use, instead of just using sort of an attribute access, you can also use a dictionary access as well. And this heralds from how you interact with MongoDB from the JavaScript shell. To know what databases you have or what collections you have in a database, you can call sort of db.collection names to get all the collection names, or you can do connection.getDatabases, I think, or show DBs to get all the databases that you have for your within your connection. So once you set, or the usual thing you'll do is you'll create a DB, a connect to the DB like we're doing here, connection.tutorial, and you'll connect to the tutorial database, and you recast that into a variable. Just say when you start going and having a look at the collections, which are similar to tables in concept, you can just do DB and then it'll be collection name or table name if you prefer to think like that. So as soon as you start inserting data, creating documents and the like, the collection and the database will actually start writing files to disk. So you can notice this as you sort of look at the file system as well. One thing when you go into production you should be wary of is people pluralizing collection names when they don't mean to, or having singles. So you might see there's multiple versions of what essentially should be the same collection. It's kind of a gotcha that takes a little while to get used to, and while you're going through Q&A and testing, you should just make sure that there are only collections that you expect to be there, because as you can see they are relatively easy to create. Yeah, so once you've created a connection and you've connected to that connection, go through, create some documents as well, play around with that. Basically, documents will be the same as dictionaries, so try adding different types. There's an example using one that has like a date in it, it has an array or a list, sorry. So try adding that and inserting it into the database, and then go through and have a look at retrieving data back as well. So let's run through the whole of this lesson. Okay, so regarding time zones and dates, when you do a connection you can pass in a time zone aware to it, so any dates will be converted to UTC essentially, but it doesn't give, the best practices are to actually cast them into UTC and then deal with them that way. You don't get full sort of time zone information about what time zone is, what date of the year is, and that kind of information. Yeah. One thing I should note is when you create a document and save it to the database, it will get an extra field. Underscore ID is the primary key, essentially, for any document. You can give or create your own underscore ID if you want, if it makes sense to for you, as long as it's unique. It has an index, so if you have a unique field, if you're doing a blog post, for example, the slug or the URL might be the unique part. You can cast that as the underscore ID. If you don't create one, we'll create something called an object ID for you, which is based on time, process ID, Mac, I think, machine, and some random integer. So it should be non-collision or collision-free, but it's not as big as a UID for. So if everyone goes through and carries on with this one and goes through creating some documents, doing some finds, running some queries and having a look. And at the bottom of this one there is some exercises to run as well. So what we try and do is we'll try and get everyone to catch up and run through these exercises. Don't forget, if anyone's got any questions, just shout out and I'll come over and help. Yeah, so next stage will be actually, or the next exercises after this one, is starting to query and add sort of refine what results you get back, and then that's where find one would be better sort of suited, because you can either do things like sorts to ensure you get like by date or whatever you need to. But find one really is a convenience wrapper that just gets the very first result back from the cursor. Yeah. So find one is literally just to help us. So instead of getting a cursor back and essentially a list of ones, it literally just takes the very first and returns that back to you. Because sometimes you just want to like literally do a get essentially and just say, give me this document, and you don't want to deal with the cursor and have that accesses because you're expecting only one. So if you did a lookup by underscore ID, find one would be good. Try running the next part will be running find one when we start adding queries, and you'll see that it'll just return none if there's no matches. But it's just literally a convenience wrapper. Yeah. So as it says here in the docs, which is news to me, so the shell treats all numbers as floating point values in the JavaScript shell does. So PyMongo is just getting the beast and type and saying OK. So the question is, how do we actually make it an actual integer? I'll come back to that one. I'll try and find out how to actually... Yeah. I'll read the documents in a bit. But OK. But it does look unexpected because of the way it's outputted in the shell, I suppose. So to actually get or cast as integers, you have to use or wrap it in number int in the JavaScript shell. And then I'll ensure it's the correct type. Shell, yeah. And then they'll come through as integers for anything, any other library that uses it. No problems. Okay, so earlier on we would have loaded some scores data into a training database with the Mongo import. So now we're going to start looking at actually querying this data and updating some of this data. So the connection part's very similar to what you would have seen and what you've just done in the previous tutorial, but this one is we'll start adding things to the find. So the way you do queries in MongoDB is you pass in a sort of a document or a Python dictionary describing the results or describing how you want to query. So the very first part here is we're filtering scores that have a value of 90, and all we do is do a key value pair. So we have a dictionary with score, and 90 is the kind of the value. And this kind of syntax expands out as you can do more and more with it. You can do things like range values, as we'll come on to, where you do things like greater than and less than to get ranges. Yeah, sure. This is available as well, so you can get it from files.ep in the PDF section and download, but I will... Hopefully that's better there. So yeah, do download it so you can follow through. But I'm just going to give sort of the highlights of it. So there are a number of areas of things that you can do, or operators that you can do to filter out and limit your query result sets. So as I say, there's range ones to check if, or check between values or dates or whatever to limit the result sets back. You can do regular expressions as part of a search to search strings, and also there's $exists, which is ensures or is to test whether a field actually does exist. Because the way you store documents in MongoDB, each document can look totally different. $exists is a way to actually define and check types essentially, or understand whether a field exists within a document, or match those that don't have it, which you might use for things like upgrading or migrating your data, or even just to understand and limit out your documents for whatever reason. So there are a number of exercises here just getting you running through, doing things like finds and limiting the result sets back. The second part to find, which I'm not sure we've talked much about here, is you can also, as a second argument, limit the fields you return. So the first part is the query, how you want to query, so you pass in a dictionary with the query restrictions, and the second part can be a dictionary just saying what fields you want to return, and you just give a true or false value depending on how you're limiting the fields themselves. And the reason that's important, it's exactly the same as in the SQL world, is you don't want to transmit all that data over the wire necessarily. And also if you have indexes, which we'll come on to in a moment, if you have indexes, you can actually just use covered indexes, just return data out of the indexes by limiting the fields that you return back from your queries as well, so make the lookups essentially much, much faster. But if we run through these examples about querying, get you running through and doing the queries, that's fine. Second part is doing sorting, so you do your find and then you apply a sort to the find as well, so you just chain them together. The syntax isn't the nicest, so you have like PyMongo, a global essentially, descending to be a descending or ascending as well. And the reason here we have to do tuples rather than doing dictionaries is because we have to maintain order for how we want to query, how we want to sort the data. Because sorting will use, essentially will use indexes if possible. So let's run through and run some sorts, run some queries, limit the results that we get back, and just play around with that.
What is the big question about how should we load the sports file? Yeah.
Okay, so did you, in the first, if you haven't loaded it already, in the first, let's go back to it, in the installing MongoDB and PyMongo section, there's a part saying, describing how to, why is that not working? How to load the tutorial data. I've got it here.
No, the question was how should we do it in the case, for example, we are working just in Python.
Oh, how should you load the data? Well, personally, if you just have it in JSON, you can still use the binaries to load the data. It's the fastest way. Otherwise, you could just run through simple JSON, just do bulk inserts, or insert the data, create documents, insert them into the database as you loop through the file. The thing with Mongo import itself as a tool is it deals with just JSON, so you don't get any of the types. So if you had date data in there or any of those things, you would lose that if you use Mongo import. So if you want to import some data in Python that you get from a feed or whatever, then actually running it and casting the objects into their correct types is a better way to do it. This one is essentially extremely simple, but say you had a Twitter feed or something that's a JSON file, you might want to convert the dates on the fly and import them into your collection rather than just using something as simple as Mongo import. So if we just go through the first part of running the query operators, I'll come on to indexes in a moment afterwards, and we'll just discuss them. There are exercises at the bottom of the page, as there will be for all of these, but I would just follow the examples, just getting used to doing it, and try it out. Yeah. So if anyone got an error importing the scores data, as long as it said 3,000 objects imported, that's fine. I think I might have a new line at the bottom where it threw an error on that. So as long as it says you have 3,000 objects, that's good. explain that again. So when you're building up your query, if you do a limit and you do a sort and things and you do a find, the cursor is lazy, so until you start introspecting and iterating over the cursor, all you're doing is building up a query for it to send back to MongoDB. So the order shouldn't really matter on things like limit and sort. They shouldn't change the results that you get back. So if you wanted to find all the values for name in the in a collection, for example here, you could just use the distinct. I think there might be an example further down or above where here we go. So example 12 is you're doing, give me all the distinct values for name, and that's basically doing a simple aggregation and just returning the different types of values that you have for that name. Was that the question? Okay. Okay, so a question was asked, how can you limit the amount of RAM that MongoDB uses? This all harks to or comes from how MongoDB does memory management in the first place. So MongoDB is very lazy in terms of that aspect of doing memory management. All it does is it tries to memory map all the data files up into RAM. So basically puts them into virtual memory, and then it's left to the operating system to manage the paging in and paging out of data to RAM. Because MongoDB doesn't have things like joins, doesn't have transactions, because essentially the idea is to allow MongoDB to scale up well across multiple and continually adding new nodes to it. Things like joins and transactions don't scale terribly well across large clusters. So we don't use much CPU, but we do use a lot of RAM. And really the only way to limit it is to either put it on a VM and limit the amount, but impacting how much RAM MongoDB can use will really impact its performance, essentially. Because ideally, all your writes that you'll do, all your reads will come straight out of RAM rather than having to page fault and read from disk, which is an order of magnitude 10,000 times slower or something. No, maybe 100,000. Yeah, 100,000 times slower to page fault from disk on ordinary spinning disks than getting it out of RAM. So, but what people do, they do employ them and install MongoDBs on VMs. That's not too uncommon, and those VMs will have a limited amount of RAM aside to them. But the MongoDB process will try and put all its data into, is all in virtual memory, so hopefully all of it will get into RAM. So that's kind of a key design decision. So yeah, if you have hosting with a maximum, then as long as your data set isn't too big, then, or I imagine you're using a VM with that anyway, that they would limit that for you. What happens if you try to cache more? Does it allow you to run over those limits? Okay. I mean, there are some small tunings you can do. You can set the, I think you can lower use small files, as when you do MongoD, you do -- small files, which will use or start out with smaller files, and you can add another flag called no pre-alloc, so you don't pre-allocate any empty files for MongoDB to use afterwards. Because essentially, when you create a database, you'll see that there'll be a file afterwards that essentially is all zeroed out. So this allows MongoDB to write quickly and then flush that data back to disk, because these files will already exist, and as soon as you start touching an empty file, it'll go and create a new one. And as your data sets get bigger and bigger, these files will be like 2 gigs in size that will just essentially be empty. So if you don't need that feature and your data set is smaller, then if you do -- no pre-alloc, I think it is, so you don't pre-allocate this space, then you won't have those files. So that will keep the amount that you need to have in RAM or in virtual memory smaller. But as these files have no data in anyway, they're never really going to be paged into RAM unless you do like cat them essentially or touch those files. So, but the small files might help as well. And if you're doing testing and things as well, set those things up for your testing systems so you don't have to use loads and loads of space, because there's probably not much need. Yeah, MongoDB is greedy on RAM and tries to use it. So, and we'll try and use all the RAM as possible. And when we talk about scaling up, everyone has their MongoDBs on a single system, and we don't care about CPU, we care about massive amounts of RAM and fast disks. Essentially, the faster disks, the easier it is when you page fault to get that data up into RAM and back into MongoDB. But it all depends on how much latency you're willing to deal with. So. So as you make indexes, which will come on to the next slide, what that will do is that will just add extra data to those data files. So those will get bigger and bigger. And at the moment, the indexes live in the same place or the same files as the data does. In the future, this isn't great for a number of reasons, but in the future, they will be split out into different files, and you can either symlink them off to different disks, or for whatever reasons you need to, symlink them onto SSDs. Some people will do. So the indexes are blazingly fast. The actual data can be slower, and so you can page indexes easier as well. So page data into RAM easier as well. But currently they're all in the same file. So if you add more and more indexes to a collection, you're going to bloat the amount of data you have on disk, obviously. So as we've just segued into indexes, we'll just give a quick talk about them. Indexing in MongoDB is very similar to how you index in the SQL world. So there are some limits. You can't have more than 64 in a collection, but that's a lot, and that would slow your writes down anyway. But there is a maximum limit of 64 per collection. And indexes essentially deal with either single values, or you can have compound indexes. If you set up a compound index and the first key is A, the second key is B, third key is C, any queries that use A can also use that index as well. So you won't need another index just on A. Again, this is similar to how SQL works with its indexes as well. So don't over-index is a main key, and a main part. The other part is for your fastest data. For reads, obviously indexes are important, and to find out what indexes you're using, you can use the explain command after your query, and basically that will give a query plan for what indexes you're using. So here is an example. Unfortunately, this one here is now saying it's using a B-tree cursor, but by default, unless you added an index, it will use what's called a basic cursor, which means it's going to scan through every single document to find your data. Later on, when you do things like ensuring index, you can call that as many times as you want. And ensure index just ensures that the index has existed. If it's not there, it will create the index for you. And basically, then when you do an explain, you should see a query plan that tells you that it is using the B-tree cursor, gives you information on how much data it's getting back, and the bounds of the query and things like that. And there's just some examples on creating indexes, so go through them, run through these, and then we'll run through the exercises, and then I think in 15 minutes it's time for a coffee anyway, so we'll break them. So if we run through those exercises there, you've done the find ones I imagine already, but creating indexes is the next part. Training. So in the background, ensure index essentially will do pretty much exactly as that. There is another command called create index, which throws an error if that index already exists. Ensure index doesn't throw an error, and you can run it repeatedly in your code, and basically the indexes that you have, that metadata is cached in the driver, so if you run ensure index and that index exists, it's not going to throw an error essentially. One interesting thing is in the JavaScript shell, any of these commands that you run in PyMongo can also be run in the JavaScript shell as well. If you don't include the parentheses, the brackets round, you'll actually get to see the internal methods of what or how these operations apply. This might be easier than going into the PyMongo code and having a look at what ensure index is, but essentially they will map and be extremely similar. So ensure index in the shell it has an index cache, and it gets data out of the index cache as well. And if it doesn't exist in the cache, it will call the create index command. But this is useful for things like in your test suite, so you don't have to then go and destroy all your indexes all the time. You can just call ensure indexes, and it'll ensure that they exist. And if they already exist, it's not a problem. Right, training. Yeah. This one up here? Ensure index. So this is in the JavaScript shell, sorry. So MongoDB comes with a JavaScript interpreter, SpiderMonkey, that you can run at any time. You can pipe JavaScript files to it. For things like some levels of administration, it's the best tool to use for dealing with things like replica sets and for sharding out your data compared to trying to use a native driver to do it. So you could use a native driver to do it, it's just a lot more verbose. So if you come to maintain MongoDB, what you'll need to do is, if you have things like replication and stuff, all the examples that we'll give, or all the administration is all done basically in this JavaScript shell rather than any native language driver. But that's more for the operations side rather than the querying and getting data in and out of side. So the question, I've just had a question, is why are we specifying an order for an index? And that might just be to how you're sorting through the data to return your data back. So it doesn't necessarily always make sense to do it, but if you're always querying where you're sorting your data, having it sorted in the index may make it more efficient, so it can use the index as part of the sorting algorithm as well as the finding algorithm as well. So otherwise, if you didn't have it and you did a sort, you would find and still use the index, get the documents from disk, and then you'd have to manually sort them. Whereas if you have stuff in the index that is sorted and allows you to do that, you can actually get the documents from disk in order and not have to run a sort afterwards. You can just return them as you get them.